The program begins by initializing the imports. Import java.awt.event.asterisk. This statement imports all event handling classes from Java Abstract Window Toolkit or AWT, such as action listener, mouse event, etc. for GUI interactions. Import java.util.hashmap. This imports the hashmap class from the Java Collections framework, which is a data structure for storing key value pairs with efficient retrieval. Import java.util.map. This imports the map interface, which represents a mapping between a key and its value. It's implemented by classes like hashmap, treemap, etc. Import java.util.priorityQueue. This imports the priorityQueue class, which is a type of queue that orders its elements based on their natural ordering or a specified comparator. Import java.util.treemap. This imports the treemap class, which is a map implementation that stores its elements in a red-black tree, ensuring that the keys are sorted. Import java.utilqueue. This imports a queue interface, which represents a collection designed for holding elements prior to process in a FIFO, first in, first out manner. Import java.awt.asterisk. This imports all classes of Java's Abstract Window Toolkit (AWT), which are used for creating and managing basic GUI components like frames, buttons, etc. Import java.swing.asterisk. This statement imports all the classes from the Swing Toolkit, which is an extension of AWT Swing, provides more sophisticated UI components like JButtons, JText fields, etc. Each import statement brings in a specific set of functionalities from Java's libraries, helping to build efficient and interactive applications. The first one of our code is frame configuration. Sets the default close operation, size, background color, layout, and resizability of the frame. And the second one is text field configuration. Configures a text field, probably for displaying questions or information with specific bounds, background color, text color, font, border, alignment, and editability. The third one is text area configuration. Similar to the text field, but with a different bounds and used for a different purpose, possibly for extended information or instruction. For the buttons, A, B, C, and D configurations. Each button has its bound font, focusability, action, listener to respond to click, and text. Answer labels A, B, C, D configuration. Configures for labels for displaying possible answers or feedback next to each button. Each label has its bounds, background color, text color, and font, etc. Time and score elements. Setup components for displaying the time left, second left, and some other information, number right, and percentage. These are configured with bounds, background color, text color, font, border, alignment, and editability. Adding components to the frame adds all configured components, time label, second left, answer labels, buttons, text area, and text field to the frame. And finally, the frame is made visible, displaying the entire setup on the screen. For that the whole frame is complete now, I will explain the next question function to the GUI now.
Go.
The next question, then it will progress to the if else condition statement. Here in the text field set text, it will set the text of a GUI text field to display the current question number. In text area, that set text, set the text of a GUI text to display the actual question content retrieved from the questions array at the current index. Then these answers labels are the set of GUI representing option for the current question, and starts a time for the exact details of timer and how it used depends on the rest of the code, which is not provided, like it seems to be related to tracking the time. The action performed action event is a method that the code that appears to handle user interactions with the quiz options and processes the user's selected answer buttons. It disables all quiz options to prevent multiple selections or changes once the users interact with the quiz. Handling user input get source. It tracks which buttons triggered the action. If the source of the action is specific button, it sets the answer variable to the corresponding option and compares it with the correct answer for the current question, then call the display answer. After processing the user's selected answer, now the display answer. It has timer and disabling user interactions, that option to prevent further user input while the correct answer is being displayed. Same buttons function as I said earlier, and here, it checks the correct answer against the user's choice and changes the color of the corresponding answer label to indicate whether the user's choice was correct or not. Then creates a brief pause using a timer object. During this pause, the correct answer labels are reset to the original color and necessary UI components are updated for the next question. It includes a condition to handle scenarios where the user has not selected an answer within the given time limit, although the specifics of how this condition should be handled may require further review and clarification. The results method is responsible for presenting the final results of the quiz to the user. Result calculates the percentage of correct answers and stores the result in the variable. This achieved by dividing the number of correct guesses by the total number of questions multiplying by 100 and converting the results to an integer. Next updates the UI to display the user's result and clears the question-related fields. The text field is updated to indicate that the result is being shown and the text area and answer labels are cleared. Then it sets the text of number right to show the number of correct answers out of the total questions and sets the text of percentage to display the calculated result percentage. Finally, adds the number right and percentage components to the frame to display the user's result. For answering the question now.